Welcome. In the last video, we talked about some basic functionality of the portfolio builder. This time, we'll talk about how to customize things and what other features it has to offer. If you haven't watched that video, we strongly recommend that you do that first. As a reminder, we have a quiz which allows us to capture our assumptions. So it's these 4 questions here. Let's answer randomly. Now, suppose that we wanted something a bit more specific than what the quiz is giving us. At any point, we can click Other Custom Setting for any of the 3 sectors, and we'll get an advanced panel. This is what the advanced panel looks like. At the top, we have the name of the sector, Global Health and Development. Then we have the type of cost-effectiveness model, which by default is isoelastic trimodal. I'll say a bit more on this. Then we have the key parameters that model uses, from the scale, the diminishing marginal returns, the probability of positive effects, negative effects, futility, etc. On the right panel, we have this illustrative outcomes distribution. This is a table that just gives you an idea of at some example amount spent, so for example 10 million, what are the likely outcomes given the model that we've assumed with the parameters that we've put in. So with 48% probability, we're having a possibly negative outcome, and then we're having larger positive outcomes with some other probability and some really negative outcomes with some other probability. You'll notice how there are dips in probability in between these 3. This is a trimodal feature where there's a futile outcome around 0 that's a mean, there's a negative mean, and then there's a positive mean. For more details as to why we might want to use that kind of model, please see our documentation and the tooltips we provided here. Let's consider a different model altogether. Suppose we just want an isoelastic normal. We also offer alternative beta models, but we will not go through these here. Once we've selected it, we first need to configure the isoelastic part. That requires 2 key values. The first one is, what is the rate of diminishing returns? And it determines the curvature. This is illustrated here in the 4th question of the quiz. So if the parameter is 0, returns do not diminish, and we have a perfectly straight line. If the parameter is negative, returns actually increase, and it curves upwards. And if the parameter is positive, they curve downwards. The greater the parameter, the more steeply the returns diminish. Let us return to exploring that normal assumption. Suppose we want returns to be 1.2, then we want a positive payoff magnitude that gives 37k value, whatever value is in our case, for example, qualies, after the first $1,000 spent. This is just a fictional example. Then we want to think about the standard deviation. And we offer this standard deviation size relative to the mean. You can see in our documentation why we think this is a useful framing. Then we have some probability of futility, 0 effect. And this is just added on top of everything else. Suppose we think it's 50% likely that nothing occurs. Then we will have our shooting graph, which is illustrating this update. Once it has updated, you can see how there is some probability, so some outcomes are around 0 because we added this futile probability, but then everything else is around what we specified. So we specified roughly this much value to begin with, and then because returns diminish quite steeply, it's almost a horizontal line all the way through. Once you're done fully customizing each of the 3 sectors, and you're very happy with what you've assumed, you want to go to the last step at the bottom. Here, there are actually 3 ways of proceeding. One is to optimize, given a decision theory that you'll choose, and given a budget that you also can modify, what the portfolio should be. A second option is to aggregate across uncertainty. So perhaps you're not sure what to put here, and perhaps you want to assign different credences to different scenarios. Here you can do that. And then you choose an aggregation method, which you can read about in the documentation, and then you build a portfolio according to this distribution of credences that you've selected. Lastly, you can evaluate your own portfolio. So instead of building an optimal portfolio, you can say, this is exactly what I'm already spending. You select numbers for each of these 3, and once you're happy with that, you'll get scores for your portfolio. So you'll get a breakdown of how different theories view your portfolio, and you can change your portfolio to see how their total score varies. Let's go back to the optimize option. Here, we select a single decision theory. Suppose that we want weighted linear utility. We can decide how much we want to discount utility. The higher the power, the larger the discount. So for example, 0.9 will discount higher utilities a lot more than the default option. We then click on Build Portfolio. It'll take some time to load. Eventually, it'll give you results. First, it'll graphically show how your ideal portfolio looks like. Then it'll tell you, according to that decision theory, so WLU, what is the total score in whatever units you've been using. Then it'll tell you what that score is per $1,000 spent. So essentially, it's saying how many $1,000 did you spend, so 100 of those, and so you divide 23,000 by 100, and you get 227. Then you get a numerical dollar breakdown of your allocation, and you get some marginal scores, which you can read about here. But essentially, it's how much the score would change if you added 1,000 more pounds to that specific sector. Unless we're in an edge case, these three would be equal if we were adding infinitesimal amounts of money. Lastly, you have two more tables. One is the actual portfolio's outcome distribution. So here, we're having 224 score with a very, very high probability. And then we're having an incredibly large score, 150,000, with a smaller probability. The tool already summarizes what other decision theories would say about this specific portfolio. So expected value would give it a score of 24,000, tail excluded expected value with a parameter of 0.005 would give it a 22,000 score. It's quite important to realize that these are not comparable between decision theories, but they are comparable between portfolios. So a 24,000 score of expected value here would be comparable to a different expected value score, but it isn't directly comparable to these three scores because they each come from their own function assessing the value of outcomes. Once you're satisfied with what you see, you can save it for future use by clicking here, and you can load those cost effectiveness assumptions anytime from the spreadsheet as we showed in the introduction video. We hope you enjoy our tool.